Hello everyone. Am I audible to you? Yes. Okay. So I think in the last session we have discussed about imbalancing techniques and right. Even we have discussed about logistic regression. Right. Today, you know what? We'll recap about the whole things. Means the journey and where the whole journey. You know. Wait, I'll just start the work. Yes. Now I think it's video. It's visible. So, what is the major work today we are doing? From the last week, we have covered the point related with logistic regression, linear regression, imbalancing technique. Even we have entered into cross validation techniques as well. So, I think today we are going to do a whole journey about it. Okay. So those who don't know about the process, those who don't know about the means implementation of logistic regression, those who don't know about um, imbalancing technique. So I will take a one example and I will do the whole journey with it. Is it okay? No? Yes. It will be useful to you all, right? So it will, you know there's so many people thinking about and they absent as well in the middle of the some sessions, so it will be helpful to them. So let's go for that, and you will get a revision of all the things, even last Sunday's session as well, right? So let's go for that. So Friday. Import pandas as a field, import numpy as a np. Okay. So then I will take a data set is equals to, today I'm just going to take a data set of different one. So it will be useful to us. Mm, I'll take data. Data. So side by side, I will check any one data, any data set I will get up. I think it will be hard disease. I will take a hard disease. So that is a small as well as we can do the many analytical process as well. So don't worry, we'll go for the hard disease. Okay. Okay, see, data set. So this is already pre-processed data set, and the only problem that we have here imbalance problem. Okay, so today, you know what, we are discussing all these stuffs. Hmm? So it will be helpful to you. Now, first I'll check the imbalancing that we have out put output dot value underscore counts. Sorry. Okay, 138 and 165. So now I'm going to slice down the data because this is an imbalancing. So side by side, we will go for the complete working about it. And wait, I will check. Mhm. Uh, this is imbalanced data set on prediction column. Okay, prediction column, because on the basis of prediction column you are getting imbalancing on that, no, so that's why I'm just passing the prediction column. But so who is in prediction column? There we have y column. This is y column, no, that's the first thing. If I'm going to think about it, first we should slice down the data. Okay, normally how much impact we get using logistic regression, we will check for that, and then we'll go for the other work, means in balancing. So side by side, we'll go for that one as well. The first one is an creating independent variable and dependent variable. So I'm just taking a data set dot ilog and colon comma colon -1. So because this is your last column, no, that's why I'm just taking that -1. And then y is equals to data set dot ilog and colon comma -1. So this is your independent variable and dependent variable. So it depends upon you that which one is means which column you would like to go for that. So there is an output column, no? So prediction purpose, that person is in height heart disease, yeah, is there or not, right? So I'll just pass here, create x and y column for independent and depend variable, independent and dependent variable. So this is we have created, not an issue. And see, the way we have passed the 165 and 0 is we are getting the 138. Now the next work that we have to discuss about it, independent and dependent variable, we what? We have to train our model. That purpose we have to create a training and testing set as well. So that purpose, create, train and test model for data set for model training. Okay. So for that purpose, from SQL, which library we have to use here? Can anybody? Which library I have to use? Pass into the chat so that I can get which library I have to take. Can anybody? Which library that I have to pass? Model selection, right? Model selection, import, train, test, split. Okay. Now xtrain, x test, y train, y test. Train, test, split. See. So this is nothing but there we have created a four variables that an x train, x test, y train, y test, and training purpose that we have taken then x train and y train, and testing purpose that we have taken x test and y test. Okay. Now I'm passing the x and y, and test underscore size is equals to I'm passing 10. So how much data size we have? The 303. So there we have the 303 rows and 14 columns. So 10 is enough for that, for understanding purpose. And random state, you are passing randomly data. Sorry, I had to pass here 0.2. So I'll take a 20%. Okay. Random state. So here we have created and applied that training set is in 20% and the random state is equals to 10. Okay. So model selection, training, testing, split. This is my class. Now I'm going to create train to the model with x train and y train. This is correct, right? We have to train our model, train to the model with x train and y train. So now, if suppose train to the model, what is the meaning of this one? You have to pass from sklearn dot linear model C import, sorry, import what logistic regression library you are going to use, because your probabilistic answer is there, no? You are going to predict the probabilistic answer. So that purpose you are adding here what, from sklearn dot linear model import what I have to pass here, logistic. This is correct. Logistic regression. Yes, correct. Right. And once I done this one, you have to mention what object. So L1 is equals to logistic regression. So this is your object, and that object you're going to pass into L1 dot fit underscore. What I have to pass? Only fit or anything? Can anybody? What I have to pass here? L1 dot fit or what? Only fit, exactly. And fit with resample, where we have to use imbalance. Is it correct? No. So now our major point is covered, that we have trained our model, right? The prediction purpose, there we have to use a y underscore pred is equals to L1 dot predict into the bracket x test, because x test has an how much data, 20% of data, so near about and then I'm just thinking about 60 size is there. So here I'm just passing prediction with x test. Okay, model prediction with x test. So prediction purpose, it's not necessary that you have to pass only X test. You can pass the multiple data as well. Means other data set you can create and slice down into the, you know, I'll use the iLog and create your own samples. And from the X train or X test, it depends upon you. You can create your samples from the X test as well and X train as well. You can slice down the data set and then you can use. Okay. But now we have done the prediction. So prediction purpose, we have to only do one thing, y underscore rate. See, this is we are getting the output here, right? For the output purpose, or you can slice down the data, you know, you can do one thing here. Z is equals to data set dot ilog into that. See what I'm doing here. Hope so you will get this point, what I'm trying to say. Okay, comma colon minus 1. Okay, comma colon minus 1. You now you got the point as you, it's now able to use, now it's able to use for the X test. But what I'm doing here, I'll pass here 0 and 1 only. So this is output that we have. The 0 and 1 means one first person that is in 37 age, and 0 means you're 61. So I'll pass here zero point 0.3 means 3. So I think you will get an 0, 1 and 2. So instead of that, I will pass here 2. 2 means 0, then 1th row will get it. Okay. Now Z is in your what? Z is your input, no? So the point is to be discussed now. Check out what I'm going to do here. So you guys are thinking about, so why I have taken this Z, right? So let's check out. I'll pass here ypred 1, and you guys are thinking about you have to pass this Z. Check out. Z I'm passing, okay? And Y, see? So actual output is an 1, 1. And your prediction output is also giving 1, 1. Are you getting point what I'm doing here? What I have done, see, your X test is also an input independent variable. And the way I just passed a Z variable, that is also your independent variable. But X test we have sliced by train test split, and Z is nothing but that we have sliced by our own side. Why? Because we have to pass the testing set. So it's not necessary to go for the X test always. You can slice down the Z as well. And not only Z, you know what actually? Uh, I'll take a 298 and wait. I just want to know who's okay. 298 and 299. Okay, I'll check some data with 20. All the people has an heart problem. I just want some scrambled data. See, I think Z1 is there. No? Just we have seen Z1, right? So Z1 has 298 and 299. So he is saying that prediction 298. See here, output is in checkout. The 57 age the person he has does not has any kind of no, he does not have any kind of heart problem. 45 age does not have any heart problem, but your model is saying simultaneously 299% 45 age he has an heart problem, but your actual data is saying he does not have an heart problem. This is correct as comparatively the way your present data is there, but the second one isn't wrong. Is it correct? Are you getting my point? What I'm trying to say you? The way I have sliced down some data into the Z and Z1 data set. So hope you are getting this point, right? Why? Because what I have done, I have sliced down the way you have sliced down the X train and X test, but on the basis of the input function, input to check the input, I have taken this much input only. See, it's not necessary that you can pass the whole some set of data set. You can take the one line as well. So see, what I'm going to do, I'll pass this one data only. Okay, this one data only, and wait, I'll go there. Okay, and model prediction with the X test. Okay, and model prediction with Z variable that created created in created previously. Okay, the same I'll pass here Z1. See the model prediction with the X test, model prediction with the Z1 that we have sliced on that. So you can write down the observational values that um, 298, 57 age 57, the actual output is actual output what he said 298 actual output 0 0 both actual output. Are you getting the way I'm just representing the code? Yes or no? The way I'm just making the project explanation, you know, whenever if you implement any project, you have to do like this one because not does not go with only one day testing set. You can create your own data testing set. You can apply on that, and this will be useful to you for the multiple observational values to comparison purpose. See the way I'm just passing the values here. The here we have the 68. No, so I'll pass here 63. Sorry, 63 and 37. Same you have to pass 37. Sorry, 63 and 37. Okay. Hmm, sorry, actually. Yeah, prediction changes the output. Yeah, wait. What is the 63H 0 and 1? Index number is in 0. Okay. So what is the output that we get? 1 1. And above when I check that, that is also a 1 1. Okay. It does not affect on the original. Okay. Check out. This is Z. This is Z1. And this is your X test. Okay. X test I am not mentioning here because so many inputs are there. But if suppose I go with wait, I will take that data set so that it will be comparison purpose. It will be good for us. Just give me 1 minute, so I will take that code. Okay. So check out once what I have done here. Model prediction X test, and I'm just passing into here. Mm, So YPRED and Y test. YPRED and Y test because this is your, you know, this is your what? This is your prediction value. Sorry, actual value. Yes. Actually, what happened? We have to convert into, we have to convert this into the numpy array. So values that we are getting into the numerical. So the series will not convert into the data frame, because here we are using a NP concatenate. So whatever the data will come into the numpy formation. So that's why we are getting the 2D-dimensional array, and the comparison purpose that I'm getting here 0, 0. So if suppose, and even you can get it into the data frame as well, but when you pass the values, you are getting into the numerical formation data, and when you pass into series, because series is important. If suppose if you are not passing a series, if you have a data on the form of series, there should be answer into the data frame. So difference, you will get it easily. The comparison, so many differences that you will get here. See, this is your actual data and this is your prediction values, and so many differences every time, every time. See here, see here. Yeah, here we have. Okay, so let's check out one more thing now. So what I'm going to do here, apply prediction using single independent value. Okay, so for that purpose, you have to use y trade underscore single is equals to L1 dot predict into the bracket. This is the today I'm just showing you all the first top to bottom complete prediction part, the single value as well as the multi value. So every observation values you have to remove this one because you have copied from directly tabular format. No? That's why we are getting this kind of structure and formats in between them. Okay. So you know the way you are passing the X test here, the similar kind of funda there we have that these are the values already present into the X test. So instead of passing bunch of inputs, I'm passing only one sig. Okay, execution, and I'm going to print this into C. So 45 age 1. So where did I have taken this one? This one. If suppose if I'm taking a single of this, you can get it easy. This is example 1, example 2. So I'll take on that single example that he changes the output because zero output is there, actual output, and but he has given the prediction 1. So side by side, why not we check about this one? See, he is right now because you know this is example 1, this is example 2. If I'm going to check a data set here, so you know that this is 45. He has says he does not have any kind of heart disease problem, but when I pass into the model and model gives you the prediction that he has an heart disease problem. Okay, so this is the way you can come throughout the whole step 1 to step end till end. Okay, till last step. So now I would like to go for the accuracy checking. Okay, means how my accuracy is working. Check the model accuracy with accuracy score. Okay, this is correct now. Is it correct what I'm telling to you? So let's go for that implementation. The first thing that we have to go for the from ASK dot what I have to pass here. What matrix import? What I have to pass here? Accuracy underscore score. Right? So we have to check the accuracy. Then AB is equals to accuracy underscore score into the bracket. I have to pass what? What I have to pass? X test, sorry, Y test and Y read, because that we have taken from this one. See this part, sorry, this one, this Y read and that Y test. See here we are getting 77% accuracy. How much accuracy we got? 77. So till the from the start to end till we are getting the 77. Accuracy score there, you know, yeah, logic we have. Actually, he's checking with the whole process. Wait, I will show you the accuracy process as well. Right. So formula that we have to show you first. Right. I'll pass the formula here. For the accuracy purpose, no. Even I have to show you one thing, that is performance matrix as well, because still we haven't gone through the performance matrix, and hope so you will get this example. I will show you the image as well. Okay, this is but formula, when you are getting this formula, when only and only if you know about the performance matrix basics. See, this is accuracy score formula, and when true positive, the words that we are in front of this is nothing but your true positive, true negative, true false positive, false negative. The wordings that we have that comes from the performance, means confusion matrix, right? Still we haven't taken any session on the performance matrix. Performance matrix has an 2 to 3 problems, like a classification report. Wait, I will show you. Because this formula you will get only and only after wait, only and only after performance matrix works. We have to take a performance matrix. Okay, in that the first we have accuracy score, second confusion matrix. Confusion matrix, and third one. Okay, these are the three. The first one only we are discussing in the last few days. Can you explain the formula shown? Yeah, actually, I can explain you, but you don't know that true positive and true negative terms. Is it correct? True positive, true negative, false positive, false negative. These are the terms that I have to explain you, because still we haven't gone through the performance matrix. If you know the confusion matrix now, then easily you will get an actual accuracy score, right? So I have to take one session on the performance matrix. That's why I haven't explained you accuracy score. Why? Because accuracy score you will get an easily, means you will get an easily by the library. Apply the library and you will get an uh, actual means accuracy score. But the point is that if I explain you the performance matrix has an huge list, means recall, precision. These are the things that we have into the confusion matrix. And once I cover that confusion matrix, then you will get it easily that accuracy score means, because here we have the the values, no, the true positive, true negative, plus false negative and false positive kind of things. So wait, I will show you some terms here. So this true positive and true negative is nothing but actually the values, the values that you are going to pass there, the true positive values, true negative values. Okay, and dividation by true positive plus true negative, false positive plus false negative, means the confusion matrix has this kind of structure. Wait, I will show you. See, your whole data set is divided into these four parts. So true positive, false negative, false positive, true negative. So what is the whole structure actually? For the explanation purpose, you will get a headache here, because I have to take a one session on this one. But then also I would like to tell you, here we have the actual and prediction values, actual data and prediction data. So actual data has a negative and positive. Means suppose just imagine, I will give you a simple example. Why this is the word like a confusion matrix. So word itself that is in same behavior of this structure. Actually, your actual output says this isn't true, but your prediction value says this is a not. But the whole structure I'm telling you, the truly positive is nothing but your data set without data set. Your actual data set is saying this is a truly positive value. But just check out about the true negative. The actual your algorithm says you say that in true positive, but your prediction value says this is a truly negative. Means your output isn't true, but your algorithm is saying this is a not true. Means you are taking a true output, but your algorithm is saying whatever the output is. Yes, you can.
Sir, now
Yes.
you are showing me that how to
Mhm.
take each variables and get the result, and another function you are creating to find what is the accuracy, and the project is solved. So if I make an engine such a way that each time that engine will take each linear equation variables like independent variables and run by itself and check with the another workflow which calculate the accuracy also, then we only need that engine for the whole entire machine learning system, because that engine take one by one like bubble sort and give the result, and it will automatically check for the accuracy. And after say 10-15 run, it will give say that if you take this variable and this independent variable combination, and this is the maximum accuracy we can find, and the whole thing is solved. Why they need a machine learning developer for this kind of job? Because we only need to make a workflow for the both cases, and the workflow will do the whole thing. So what is the logic in this thing, the whole process? We only need to find the whatever you taught us can be implemented in a workflow, and the workflow will do the job.
Yes, that's correct.
Then once the workflow is done, release in the market, the whole ML job is lost, because this workflow will do the needful for every company.
Yes, yes, that's correct, sir. Actually, you are saying that if suppose workflow means your life cycle is in front of you, and your life cycle is means it's kind of stable journey start to end, then this concept will useful for all the peoples, and they can use easily this one, right? Then what
And
is
there
the
is no
difference
more
between that you are
there
telling,
is no
right?
more there is no more useful job for ML developer, because this workflow, once this workflow is a success, then all people need to buy this workflow, give the data to this workflow, and they will get the
Hmm.
desired output. There
See,
is no job in ML.
not like that, sir. Actually, just imagine
Mhm.
workflow is the same, but your data is changes every day, right? Your data is
Let
not
it
stable. Your
let it change,
workflow
because this workflow will take the individual run the sequence for 10 times, and will give you the correct prediction and correct accuracy, and everything is done in a cycle. Let the data change. I will run the workflow once again and get the desired result. Because if the first run is wrong and the accuracy is not accurate, it will go for the
hmm,
second run, like third
hmm,
run, like our
hmm.
blood test. We run the blood
Yes,
test,
yes,
and
yes.
sometimes it goes wrong. We do the blood test once again. We get the
Hmm.
correct one and get the
Yeah, that's
conclusion.
good. That's correct.
Then what is the
That's
use
correct.
of
Not an issue.
a
Machine
machine
learning.
learner programmer in this area? The whole thing can be
You-
done if somebody done in a single workflow. This one workflow designer. Since
hmm.
I am a programmer, I know that this kind of, it will not take much time to release one workflow like this.
See, yeah, it will take on very easy when you learn the process. No, the step by step. Once you get that, very easy to implement this on all these things. Not an issue. And the way you are telling me, no, the same thing. I'm just thinking because I'm a full stack developer, though. So I'm thinking about the whole journey is in same, right? The way you said, no, the same thing. I'm just thinking about that. The workflow isn't stable. Workflow isn't same. Why not I take only data set? So many, even Microsoft generated same means you have need not to create this workflow. You have to put a data set and go
Yes,
for the execution directly. Even I
yes,
think
and it will
one of
give the best permutation possible by this workflow.
yes, yes, sir, not an issue. What is the
So
major
like
part?
the like you are training the ML, the training
Hmm,
engine itself can be done in a workflow. Like you are
hmm,
predicting you are using a different command for the prediction. That also
hmm,
can be used in the workflow, and whole
hmm,
output can be given in a single matter of time. The powerful the engine is, the time it will reduce into single, say something like a half an hour, 10 minutes or something like that. You will get a best possible output. Then why
yes.
we need to go for this thing?
See,
This can be replaced by somebody, some workflows.
the stages will not be replaced. the first thing,
It
because
will
the way
be,
we
because see,
hmm,
once you get a data set, maximum
hmm,
how many logics you can apply, that can be implemented in the workflow. So the workflow or workflow design engine only need to select this engine. After that, go to this one, get this one, and repeat this cycle, the whole cycle, and implement it. So
the
this will
same
not take
process,
much time.
it will not take so much time, sir. Actually, you are a full stack developer, you have means deployment knowledge. That's why you getting this kind of question, because you are getting the whole means the whole stages till the performance matrix now, means accuracy
Yes,
score till you are getting everything. And you know that you can take these variables and connect with the web development, means web pages, and you can create a model easily. Only select,
yes,
upload the data set, select the column names, and select the prediction value, and that's it, submit. And if suppose at the even I'm thinking about the same, I think the way you are saying, this stage, wait, where is this prediction stage is there, right? Now I'm
yes,
using here logistic regression. You can create some tabs there for that, and click logistic regression, get the output with the same input variables and output variables as well, right? Is it
yes,
correct?
yes. Then see, now you are telling to apply logic regression. There may be a
Hmm.
lot of similar logics inside the system, and we don't know that, because day by day somebody else will be releasing another logic better than this logic regression, because
Yes.
this logic is available only in sklearning. Maybe some other library has got different logic better than this.
Yeah. Yes. Yes.
So this library, this workflow model can just upload one model, just
Hmm.
select which algorithm which you need to take, then select which data set you wanted to go. Then according to that, it will run, and it will go for the, once it is running, it will go for the accuracy, whether this accuracy is meeting our system. Then it will go for the next run till it go meet the accuracy. Then it will give us the
Score.
output, say that according to this model which you have selected, this combination of independent variable give you the maximum probability of output, and this we only need to go for it. Why to take
Yes, sir.
hassle?
So it's kind of, once you learn about the the life cycle of waterfall model, or if suppose life cycle of that another one, agile network, the stages are fixed. You have to do from this one the same structure that we have in the machine learning model as well. The way you are seeing in the last two sessions also, you have seen this one, right?
Yeah. So
And
because
yes.
why I am
Hmm.
telling this thing, what is happening inside logical regression logic, we don't know, because we are not teaching
Okay.
it. We only need to, we
Okay.
are only taking that this is the function passing this variable. But I am just standing above that thing, say that this is the data set, this is the logic, run. A model can do all those things which you are taking each and every component to make a model, and take a
Hmm.
step above and make a model such like that it will take a library, it will take a
Hmm.
linear equation logic, then it
Hmm.
will take a data set, it will itself run everything. We don't need to find which one is the possible thing, and it will go for it.
Yes, yes, yes. Now means the stages are set, but behind the logic, the way we have covered in the linear regression, the way you get that linear regression is getting this kind of logical thing behind that. The similar kind of that, I think we haven't gone through the logistic regression, right?
Yeah,
But
we don't know what is
sir,
inside it.
okay, okay, we'll go for that. Actually, that PPT presentation that goes through the tomorrow as well, means logistic regression as well as the KNN side by side. Why? Because we still we haven't gone through the last till accuracy score. That's why I haven't gone through the logistic regression, right? In the last session also, I never mentioned the logistic regression, because life cycle still not covered. That's why imbalance, why we have taken, because we have entered into the classification problem statement. And if suppose if I explain you logistic regression, and after explanation we are getting the imbalancing, that time what will happen, I have to explain side by side logistic as well as the imbalance. So that's why I have taken first imbalancing problem to solve this one, and then we are going to enter into the logistic. So tomorrow, means tomorrow session, that is explanation of logistic, means logic behind the logistic regression. Even KNN also tomorrow we are going to take. But the point that you have said, no, that the stages are fixed. Stages are, yes, in the ML, stages are fixed. Only you have to change the, libraries. That logistic regression, if you are using, then you have to change the algorithms, second algorithm, third algorithm. But the thing is that till the sum of the two or three algorithms are same, means easily you can implement. If suppose if you are going with the KNN, or if you are going with the suppose another one, there is a decision tree, there isn't some of the work that we have to do. But stages are same, means the first, second stars, you have to upload the models, or you have to do these things. These are the same. You can't change anything here. Even I can't do this one. What if, sir?
So what is your conclusion, sir?
My conclusion is, sir, the stages are fixed. And see the logistic behind the, means logistic regression logic behind this one. Tomorrow we are going to implement the explanation of this one, because PPT explanation is there. But if suppose, if some of the queries that you have, means logic behind this performance matrix, this is also we have to take one session. Not only accuracy score, we have to go on through the all this process, means classification report. Here we have confusion matrix, classification report, and accuracy score. This will be held into the another one session, because with the explanation of algorithms, we cannot go through this one. So, and whenever if you are getting any question, is this like the way you told me, that you can tell me about that. We have to go for this one, and I will take a time, and I will go for the explanation as well, right? So whenever, but the process now is same. Logistic regression logic, tomorrow we'll go for that. And performance matrix, I will have to take another one session for this one, individual session. It will go for the, I think I'll take that session in the next week, or in the Sunday as well, because it will take on more than 2 hours. There we have so many definitions: recall, precision, TFR, means true positive value, false positive value, true negative values. These are the things that, so many things that way. So that's why. Yes.
Sir, you are telling us that whatever things which you are going to teach us in the next classes. What I am asking, the things which you are taught, can we put it in a model? The whole thing put it in a model, and the whole regression model can be implemented in a model. And tomorrow Microsoft release a new product, say that only upload this data set and select the data and
Yes,
select
I
the
have, sir. We
this
have
one.
the same software.
Then there is no logic. Then there is no need of a ML developer.
That actually we see.
Yeah,
Creating a website.
what I am asking is, what is the factor which a model cannot do, and what is the thing only a ML developer can do, even though Microsoft implement a model? That is my basic question, and that is the answer which I am trying to get it from you, because there are not less than 10 to 15 students are there in this class. These 15 students will be developing 15 models, and we will go for 15 result. In this one, which will be the best one is to be for the
Prediction
organization
purpose.
is depend upon the accuracy and rest of the factors which you are told. A model which is developed by the Microsoft will do the same, but there will be something, or is there any something which only a ML developer can do, a model cannot do? That is my question.
ML cannot do. Say this is the whole structure is in completely R&D based. If suppose out of the box, we have to know first the behavioral part of your algorithm, behavioral part of data sets. If suppose the way I'm just logistic regression, if you learn whole this process, then you will get to know that you can do out of this one, right? If suppose the behavior, how many ways that we can solve, that we are learning, no, where we have the logistic regression, if suppose other KNN and all. These are the things, these are the algorithms we have, and we can solve these problems with this one. But if suppose out of this, if you're going with that other concept, then first we have to know about this process, whole process, and then we should go for that. That's the thing I'm just thinking about that. If you
But
don't know that,
the thing is that, see, we learn this thing. Car driving is easy, and we learn this thing, and because the car is affordable. We are not learning flight learning because it is not affordable and it is not easy. So we just pay them and use it. Like that, Microsoft is tomorrow release a model, then we don't need to study all those things. Just buy it and use it.
no, sir. Actually, we have the module as well. Even we have the Microsoft software. Actually, I will tell you
We
in
have
the
that.
next session that we have. Wait, I will check that one. Actually, I heard about that. Microsoft has this kind of machine learning software. Wait, I'll tell you. So that's why I'm just last point I told you. Machine learning. Something kind of. I think Azure machine learning, create your free account.
Azure is only a cloud mechanism.
Yeah, Azure, Microsoft Azure is a cloud mechanism, but in that also there they have automated machine learning module. I haven't checked, but I heard about that previously. Virtual machine learning, Linux, virtual machines. They have mentioned there. Don't worry, I will go for that. But sir, if suppose predefined models are also there, but we have to know about some algorithms. No, so I can once you learn, then you can go for the implementation. But the way you said no, once the log softwares are in the in in all industries are in all the industries. If suppose software like this one, so industry will use itself. Why to need ML developers? The same question that you have asked, right? So
Uh,
Azure machine learning software is there actually. Azure machine learning. If you know, go for that. You once check. Build, train, deploy machine learning models with the Azure free account. Wait, I will share with you in chat. I don't know the whole process. Check out this. You got the link now. And the question you said no, I will go for that question as well. Means why to need machine learning engineers if we have the softwares, right?
yeah, the first one, automated machine, identify suitable logic,
Yes, yes, yes.
algorithm, and hyper parameter fast. So the ML
Ah,
job is done.
the way sir, the way you are experienced, I know, right? And definitely this kind of question, even I got that previously, but I will check that output. Means check that question's answer because dedicatedly the positive answer should be there. So if we have a software, then why to go for the machine learning models implementation, right? I will tell you definitely why we need this to learn.
Okay, sir. Let's continue class, sir.
Yes, sir. Thank you. Yeah. This is total. We got it here. So we'll go for implementation of quick explanation of imbalancing that we have used. And even I will show you uh, the one thing that is imbalancing in model, that is a cross validation problem that we have, right? I would like to go for the oversampling. Better to go for undersampling because undersampling impact is not that much, but oversampling do much impact on them, right? Undersampling reduces the data, oversampling increase the data, and it will be useful to train our model, right? So I'll use that one. And you can pass this example into here means into resume as well, means for the heart disease analysis and prediction as well. But you have to know the every stage about it, right? Every stage. I'll use that previously created our code here. Random sampling, random oversampler, R1, random oversampler. This is what is the oversampling technique that we can, what is the work of that random oversampling? He will increase the minoritical categorical data into categorical count till majoritical count. So that's why we are having here x underscore data and y underscore data is equals to R1 is nothing but random oversampler. So fit resample x comma y. X comma y is nothing but your independent variable and dependent variable. So both data set size we having 300, almost 303. Okay, and just check out. I will use the counter as well. To counter purpose, I'll apply this one. See, after oversampling, we have 160 by 165, and then apply the this apply the algorithm. Okay. See, stages are same, not an issue. Once you define, not an issue. Once you define, it's not like that we have to change the structure, but algorithm you can change it easily. Okay, L2, L2. Sorry, actually I have to create here one more thing from sklearn dot model x1 print x1 test y1 print y. Will put a same test size and same random state. Okay, sorry, actually. L2 dot predict x1 underscore test. Okay, so x1 test is that we have created here. This one, X test. Y1 test, this one, and this is your Y pref. Okay. So, see what we got. After oversampling, we are getting 87, and here we are getting how much accuracy? 77. So 10 points are increased here. Okay. And actually, the major thing is that with the oversampling, how much data is increased here? Almost 27 points are increased with the oversampling. And oversampling main content is that he is increasing itself, means the mostly chances to be the duplication of data here. But avoiding this duplication of data, there we have the another one, that is the smooth. He can create a not a duplication of data. He can create itself the own data, means artificial data. Now we can implement the smooth as well. It doesn't matter. But we can do one thing. We can implement the smooth, and I will tell you what is the major drawback we are getting where. Okay, implement the smooth, and we'll go for that point discussion mode purpose. Okay. So I'll use the same here. The smooth purpose, I'll have to use direct sum out T smooth. But I will change one thing. Okay. Balancing will come same automation. Y2 data. Then Y2 test. Here we are getting same actually. Anything that I have changed or not? X2 is correct. But I'll check on data as well. See the smooth and oversampling getting same output accuracy, right? And the point to be discussed here, getting same accuracy. Wait, see here, I'll pass y to test. Okay, y2 train and y2 test. Actually, this is very rarely we see this one, that your data isn't balanced into training and testing set. When training and testing split completed, the maximum chances of imbalancing in the model means in the creating of train test data set. So here I think maximum times, very rarely we get a balanced. Here we are getting the balanced. No. So same thing if suppose if I'm trying to go with this one, very rarely we are getting this one, that your data isn't balanced in training testing split. So if you try to go for the some other example, no, with the not an only heart disease, if you go with the credit card fraud detection also, there is also we will get in some imbalancing into the training testing split of data. While you can means you have done the point of balancing, but after the training testing split, we are getting this point of this kind of imbalancing problem. So check out, this is imbalance now. Say this is also a balanced data set because y1 test and y3 test and having the same count of ones and two zeros. Here also ones count in 33 and zeros count is in 33. But the point is that what is the sum of this one 13 13 and then near about 333. Okay, the same thing, just I will go for this one. This file is useful to you guys because here I have implemented start to end whole process. The logic behind that we can go for that next class as well, but some of the logic that remain will go for that one as well. See, here we are getting the imbalancing into the model. Here we are getting imbalancing, and here will not having any kind of imbalancing. The complete data is unbalanced, where in the oversampling technique, see your data is in here balanced, and if suppose if you think about original means your plain data set without any kind of imbalancing problem we added. Are you getting what I'm trying to say here? Means what we have done here, we are getting the imbalancing, no, while adding in train test split. But how to solve this problem? With the cross validation. You need not to go for the cross validation when you have a balanced data into this one, means in this oversampling and undersampling. But you can go for the balancing, means cross validation technique here you can go for that. Sometime after oversampling, after undersampling, or after smoke technique, we can get imbalancing problem. That time you can use the cross validation problem statement, means cross validation techniques. But don't worry about it. I think if we cover up this one, no, this whole process. Like now we have covered ML process fully. So how to implement the first stage, second stage, third stage, fourth stage, even accuracy still accuracy score. So what are the points that remaining about to discuss? That is that is the first remaining in performance matrix, second algos, third one cross validation concepts. These are the points majorly remaining into the machine learning, right? And once we covered no performance matrix and algorithm, remaining algorithm, cross validation concept, then we can go for the implementation. Means what are the little points that remaining into whole process of this one, no, that we can cover up. But the way I just implemented whole journey, it this can be complete process, top to bottom till performance matrix, right? And we'll go for that. Okay, everyone. Are you getting this whole process now? What we have done in the today's session as well as the till now, whatever the content that we have. And one thing is remaining here. This is also we can add here. That is mm, imbalancing occurs after overbalance. Can you please repeat how to imbalance occurs in oversampling? Yes, yes. Wait, just we're going to use here standard scalar. Okay, normalization. These are the points that remaining. So it will be useful to you. Okay. Where, sir, in the oversampling, no? Actually, oversampling, what is the major work about oversampling? That here we can do the balancing, no? So we got in 165, 165 here. But the point is that just think on it. You are passing a random state here, right? 10, and you are passing the test size 0.2%. So what is the possibilities that your data will equally divide into the X train, X test, Y train, Y test? Are you getting my point, sir? If suppose if I change the random state, if I change the test size, the maximum possibilities that data should be goes into means imbalanced. If suppose we'll try for that. Wait, if I pass 1, we'll go for 2.5. Okay, wait. So see now. Now got the point. Now you are getting a imbalancing into the model. Why? Because your data is in balance previously, but when you pass into the training testing split, no, that time definitely you are getting imbalance here. So you guys are thinking about here we can use the imbalancing one, means here we can use the balance, we can do the balancing or what? No, you can use here cross validation technique. What I'm telling to you, cross validation technique. Cross validation techniques that helps you to create a multiple folds, multiple ways to pass the test cases. Means you can create 5 to 10 iterations. Here you are getting a single iteration in applying the same test size, test case. But with the cross validation problem statement, you can apply different test cases on the same data set, so that your accuracy would be increased. So here you will not get, means when you apply the cross validation technique, No need to think about imbalancing. Are you getting, sir? But before you go for the cross validation, you have to pass balanced data into trend test plate. Else, the whole process will. Next day, I'm thinking about the logistic regression explanation. Okay, side by side, I will take that basic working about this one, because these four factors, no, these are important, right? But I will take a one three three examples are there, means three types of their cross validation. But I will take one of them in tomorrow maybe. I will go for the logistic regression explanation, and I will take cross validation. One, any one of them. So it will be helpful to you to understand that point. Okay, I'll go for that. Yeah, sure. So see, today we have done imbalancing as well as the whole process of heart disease prediction. Okay, and go for it. I will share this file as well, and this is useful to you file. The first time that I have done the top to bottom explanation of any project like heart disease. So this will be helpful to you. Okay, so I will share this file to you. So see you tomorrow on the same time, and thank you so much. Take care of you all. See you. Bye bye.